Sea level. What's about sea level? Of course, it's the parameter in this discussion which poses the only real threat. From a sea level rise there can be nothing good coming out. If it gets warmer, at least Fennoscandia would be happy, and so on. So, this is me, this is my institute, this is what I'm going to talk about, but I will diverge a little from it. And I have been working on this topic for 45 years. I am an old man. So, okay. It is obvious why we need to keep the information correct. Coastal evolution, that's what I'm going to talk about. We don't like ignorance. We don't like exaggerations. Both lead to bad things here. We need to have a sound evaluation, and that is what I'm trying to do. Okay? And I added something, because many of you are not sea level specialists, there is none of you. But something about what is sea. Why would sea level rise? If the ocean volume would increase due to glacier melting, okay, that's obvious. If the water column would expand due to heating. If the water mass would move laterally, okay? And that comes the more input. All these factors can be handled as to rates and amplitude. Quod erat demonstrandum. Those who don't know Latin, which I will try to show to you. If we put the rates and the amplitude in meters per century, because you always say a meter in a century, so this way and that way, we can put the frame, physical frame, inside which you have to be. If you go outside it, you are in trouble, because you upset physics and geology and other things. During the whole of the rising sea level, take for example the Variability curve, the mean rate is 10 millimeters per year. We had an enormous amount of glaciers. We had an enormous forcing. Still, sea level rise was only 10 millimeters per year. When we had in Stockholm, for example, ice melted, ice front melted with 800 meters per year. That's an enormous rate. Still, sea level didn't rise more. So that gives us a frame. If you are outside that, you are in trouble. So we should be inside. IPCC here is here. This little box is during the variability in the last 300 years. In the beginning, we heard about glaciers melting globally, and we got figures of 24 centimeter in time scale of unknown, or 450 millimeter in 30 years. Those are far outside. It's absolutely impossible to put sound physics in. The next one is expansion. We can expand the water column. This being the water column, and this is the expansion effect. If you have 5 centimeter, 2 centimeter, 1.5 meter, of course it's the upper 300 meters which is being heated, or maybe 400 meters, or maybe 700 meters. But that's, if you take for us 2 centigrades, that's an enormous heat. And if you do that, sea level would rise 10 centimeters. And then if you go towards the shore, remember that we are talking about the shore. That's where the flooding should be. If it's 100 meters depth, it's only 3.5 centimeters. If it's 10 centimeters, you are coming closer where you are swimming. It's only 3.5 millimeters. Who cares about that? And when you come hit the coast, it's 0, because there is no water to expand. Some people think that it will flush in, but then they don't understand the dynamic sea surface. It doesn't flash in that way. So this is important. What am I doing? So the next thing, sorry about the French spelling here. That is the El Niño change. Water was about 30 centimeters higher here and lower there. And in this month, moved from one place to another. We can see that at larger scales in larger time units. And so those are the three parameters. So sea level changes. The true facts are to be found in nature itself, certainly not in the model tables. Sorry. Now we are saying this is satellite altimetry, a map. A map should fit with observation if it should have any meaning. What else? Why should we use it if it doesn't fit with observation? This is a big rise and there's a big fall in sea level in the Pacific. Let us check critical areas. This is Tuvalu, but everybody says, including Ban Ki-moon, that very strange person, saying that sea level is rising terribly. But look at the records. It's completely stable. And this is an improved data set here since 1992. It shows the same. This being, of course, the last big Ensweber. And if you're Kiribati, or Kiribati, you say same thing. There's no rise at all. And if you go over to this place where it should fall, you have, for example, the Galapagos Island. This is completely straight, of course, with the Enso here, plus, positive. And if you go to Hawaii, where it should be the largest thing, here is more complicated, but at least it's not a fallen here. So why should you have a map if it doesn't fit? What am I doing? Yeah. So now I'm talking about the Indian Ocean, because you have heard so much about the Maldives being flooded, the president claims, and the Bangladesh, which is a terrible place for flooding, they say. So we will investigate that area. I just put here in Venice and Northwest Europe, because there we can test the so-called geostatic factor. That is a factor of the pure global, or whatever you call sea level rise. Kiribati and Tuvalu was here. Okay. They were flat. And now we're going to see this area. What should I do here? Well,
just go off screen.
Okay. So this is St. Paul, where I had a very good measurement here back in 1970. See, there is no rise, and these are the IPCC and the global loading models. They are far, they don't conquer this. We come to Maldives, where I have done a lot of work. This is the sea level curve with 57 data points. It's going up. Most of those changes are certainly dynamic changes, movements of the ocean, but not volume changes. But it's interesting, here the Buddhist came, so they have survived all these variations. Interesting. But I will, of course, concentrate on the last part. You see 1, 2, 3, 4, and this is 1 and 2, the mean and high tide level in the lagoon. This is the higher level, number 3. It's here, it's about 20 centimeters high, and number 4 is this. So in morphology. We also have peat here, which changed into a lake, all dated. The lake dried out, so it's a low sea level, a high sea level, and lower sea level again. Erosion. Some people say that erosion means sea level rise. No, not at all here, because you can see the sand being taken here. This is the old shore of that level, 3. The erosion took the sand and brought it outward and longshore, but also downwards. The new high tide level is here instead of that. If sea level would rise, this would have gone on to it. Simple as that. We have this tree which is sitting in a delicate position. It has been there at least for 40 years. Just a simple little rise and it would have been gone. We have a double rock cut platform, which I will show you here. Here we have a map from 1922. See what's here. This is now being abandoned and start to weather. This is the new rock cut platform. This is the fall at around 1970 called the Fisherman. It could be a little 10 decades old. Here you can see that it's still in the process of being eroded. If sea level would rise, it would have attacked this. It's not a sign of such an attack. So it has been a stability. So when we have this, a lot of data points, different. And here the stability for the last 40 years. The president says something, the president in water, the cabinet underwater, in order to raise interest of especially getting money. And here is our estimate of the future. So if things happen here, it's just return to this position, which means absolutely no threat. No, sorry. I pushed the wrong one. Look. Oh, sorry, continue. Lackadives is just north of the Maldives. It's the same geology. And the man here is pointing at the previous sea level position before the flood. And they all know that there's no trace of sea level rise to be found. They are amused what the President Morner says, and they understand that it's all a matter of money. So after a fall in sea level, it has remained stable, and it starts to overgrow, exactly as it did in the Maldives. Now to the Bangladesh. So people would see a situation like this, and sea is rising. But you have not looked carefully enough, because you have to investigate the trees. What does this say? The horizontal roots, these mangrove trees. It means that the mudflat must have been above this. And here we have the present, the older matter. So it's easy to put up the original mud flat, and there is no change. So it's no erosion. It's erosion, enormous erosion, but absolutely no sea level rise. This is interesting. If we go to the tide gates of Mumbai and on the other side, it's a similar thing. Stable, rise, fall, stable. See, that is very similar to what we saw in the Maldives. And I just returned from Goa and made a new sea level study here. We have a high here. It's a 60 centimeter above the barnacle ring here. We have harbors here which are now drained. We have harbors which have submerged 1.5 meters. We have this rock cat platform, which starts to be overgrown. And now we have the barnacle one, the present one. That is stability, and that has been stable for a long period of time. This is the barnacle ring, and this is the present active shore. This is the somewhat earlier, about 20 centimeter higher rock cat platform, and that is the dead tree, now overgrown. It's no longer active. So that's how you work. So the Maldives, the Bangladesh, and now Goa and India gives very similar stories. So there is no sea level rise in Bangladesh. That is interesting, because this man said it's the worst, most vulnerable country, yes, for flooding in the water in the Himalayas and from cyclones from the sea, but that has nothing to do with sea level rise. And this is interesting what they said in 2005, that 5 million people will be climate refugees by 2010. We have passed 2010, and there are no one. So, and there are many lies and exaggerating to people may behave so, maybe, but trees don't lie. That's very nice. We can rely on the trees, this one and that one. This one had such a delicate position, so it was stayed there until a group of so-called Australian scientists tear it down by hand in order to destroy one of my places. Just not so nice. Then we say, I give you a little example. What could I be talking about the Indian Ocean, but about the global context? We just touch upon it. This is the rate of rotation, slowing down in this rate, speeding up. So it's a log. If sea level would be rapidly rising, following the law of angular momentum, the Earth should experience a deceleration. This is not the case. Why is this? Because sea level is not rising. Of course. So, you have this speeding up instead of slowing down. This is interesting. So, they did pictures like this in 2010. I think instead of saying global warming, I say global warning. It's disinformation and misunderstanding there will be no flooding in the Indian Ocean here. For me, it's important because putting the focus on elusive sea level rise is to steal the limelight from real problems in the real world. We therefore urge back to reality as observed in the field. And if anyone is interested in the discussion about measurements of present sea level rise, you have it in this paper, and if you want other, you are here, and I would be happy to send it to you, I will give it to you. It is in my computer, and if you want tough reading, you can see this, The Greatest Lie Ever Told, with a modest title, and unfortunately I have to send it. But this is the end of the story. Okay, thank you very much for your attention.
This is just anecdotal, but I know of islands in the South Pacific where Captain Cook in the 1700s visited the coral atoll regularly because it was a source of fresh water. And today this same island is, the water source is very brackish in this interior lake. But that is only because, not of sea level rise, but because there are nearby volcanoes that are forcing the island downward. Now, in what you discussed, you did not mention local changes in the heights of the islands relative to the global whole, and that surely has to be an issue. And perhaps there is sea level rise, but just the islands are keeping pace with it because they're rising.
So right, wrong. But this, as a geologist, this is a natural thing for a geologist to do. You have always to evaluate the crustal component or the compaction component versus the so-called sea level. This is, of course, what I have been doing. So to say, in this forum, I have concentrated. What else could I do? I couldn't speak for days or years about the pure sea level effect. You have this water intrusion, which could, in one case, as you said, volcanic. Most other is the withdrawal of water because people are drinking water. Okay? And then or irrigating, which the Japanese permitted. So they pulled in marine water. They have nothing to do with the sea level rise. It's just that it took out too much. All these things have to be considered. Yes. So that's why I have concentrated to show good places of stability. Indian continent, supercontinent, is very interesting with the Deccan Plateau. To have similar tide gauge record from both sides really shows what you would expect, that this huge block is more or less stable. It's interesting then to go to Bangladesh, which is also a deltaic area, but it has been said to be a rise. But if you look at the basic data, it is really not so. And Maldives the same. What you check on is, of course, the last interglacial level. That tells you something about what's going on. But you are right.
You certainly have some impressive and maybe heartening examples that we have nothing to fear. I wonder if you could comment on the fact that worldwide tide gauges with directions for land moving up and down, and then the Topex Poseidon and other sea altitude satellites all show that in general there's warming or a sea level rise, albeit small. So while at different places you may not see it, are you saying that the satellite data is wrong?
Yeah. Okay. First of all, yesterday we heard Rihanna saying don't extrapolate the satellite data into rates. She's very clever in that. The other thing is that, and that is discussed in the paper I just showed you, they have added corrections. It's a wonderful tool that if you have corrections, it's completely correct to have corrections, but you must specify them. If you don't specify them, who knows what they're. Those corrections are discussed in that paper. And if you do that, you can withdraw a lot of them. If you go to the tide gauge records, it's right that it's 159 tide gauge stages we know is using. But the majority of those lies in a band between 0 and 2 millimeter per year rise. So there are the majority, and then you have uplift and subsidence, of course. But in that box, it's interesting to find. And then you can scrutinize. So what have been done, for example, in the IPCC studies, is one is using 25 out of these 120 records, the Douglas. Then it's your colleagues, Church and White. They are using 6 out of 120, and Colgate 29. It's very little, so you have to go to better data set. Yeah.
Okay, I think we